Hi everybody. In this video I'm going to show you how to graph a quadratic function, and I'm going to do this by focusing only on two things: getting the x-intercepts by factoring and using a table to create additional points for your parabola. To factor, you have to remember that you want to first start by looking at your expression and seeing if there's a greatest common factor to pull out. Now I see that my leader here is a negative, and just remember that there's actually a -1 right there. So I want to pull that out because I want my leader to be a positive value, not negative. So the first thing I'm going to do is I'm going to divide each of these by -1. And I use a -1 also because there is no other number that divides into all of these coefficients and constants other than a 1. So anyway, so this is what I get. I get f of x is equal to -1 on the outside, and then the answer to these divisions on these three terms goes on the inside. So when I divide these two, I get a positive x squared. When I divide these two, I get a -2x. And when I divide these two, I get -3. So this is one step to factoring. Now I also need to see if this trinomial can be factored into two binomials. So what I mean by that is I want to see if I can take this and turn them into something like that. And what I want to do is use something called a crisscross method that I have learned, and it goes like this. So you set up an x, and you look at your first term, which is x squared, or 1x squared, right? There's a 1 there. And you ask yourself, okay, what times what makes x squared? And that would be, well, if I put an x there and I put an x there, x times x is x squared. And then you look at the last term and you think to yourself, okay, what times what makes a 3? So you can put 3 and 1, or you can put 1 and 3. And then you go ahead and you crisscross, or you cross multiply. So doing that will give x times 3, which is 3x, and x times 1, which is 1x. Now, you want to ask yourself what you can do. Sorry about that. You want to ask yourself what you can do to combine those two terms to make a -2x. Now, the only way to make a -2x using these two terms is by subtracting them. And because I need to make a -2x, my negative sign should go on the 3, making that -3x. So when you combine them, you get -2x, and this matches this. Okay? So then the other question is, all right, well, this negative would go here, and this being positive, this would go right here. Now, if you take a -3 and multiply it with a +1, do you get a -3 here? And the answer is yes. So what that means is that this combination of numbers, it satisfies both the constant and the middle term, your b term. So what I do now is I go ahead and I grab this, and I grab this, and I create my two factors. And that would be the following. So it's going to be, and I'm going to move it over here to the side actually, this way. That's pretty messy, so let me do that again. I'm going to go this way. Okay, so now it's going to be f of x is equal to -1 times x minus 3 times x plus 1. Okay, so the factoring part is done. Now I need to go ahead and solve it. So this is done. So what I'm going to do now is solve. So this is now step 2. So solving now involves taking this this equation that I have, which is, I'm going to write it over here again, taking this and now solving to find out what values of x I need. So the first thing to do is you need to take this f of x and you have to change it into a 0. There's a reason for that. The reason is the purpose of solving is to determine the location of what are called the x-intercepts. Now the x-intercepts will be points on the graph itself that sit on the x-axis. It's where the graph will cut through this x-axis here. I don't know where that's going to happen, and I want to see if it's going to happen at all. So by making this a 0, this is like saying y is equal to 0. And when you're on the x-axis, all y's are 0. So this is what I have now. Okay, and what I can do is I can get rid of, you see this -1 here? I can get rid of the -1. I don't need it. So I'm going to divide -1. And yes, you can do this. Divide it out, and what you get is 0 on this side is equal to x minus 3 times x plus 1. With that -1 out of the way, you can focus only on what's inside. Okay, now the way to understand this is like this. I am looking for a value of x that will turn this group into a 0, and I'm also looking to see what value of x will turn this group into a 0. Because you see, the whole idea is you're multiplying two groups, this group times that group right there. And when you multiply them, the result is you get a 0. And that's like saying, when you multiply two things and you get a 0, then either this had to be a 0 or this had to be a 0. And because you don't know which one is, you find out the value of x that could make either group into a 0. And so you split it. Oops. So you split them, get rid of these. And when you split them, what you do is solve each one individually. So you say, all right, what value of x minus 3, or what number minus 3 would make a 0? And what number plus 1 would make a 0? Now, obviously, 3 minus 3 would be 0, so here the answer is 3. And -1 plus 1 would make 0, so the answer here is -1. So what you do with that is you go over to the graph, the coordinate plane, and you think, okay, well, I have two answers here, so I have two x-intercepts. One is going to be at -3, at +3, which is right here. This is my x equals 3. And the other one will be at -1, which is right there on the border. Okay, those are my x-intercepts. You can see that they're sitting on the x-axis. And so I get 2 points for this graph by simply factoring and solving this. But the problem is that 2 points are not enough. And I don't know if this thing is going to, how high it's going to go. And so I need more information. I do know that it's going to be upside down. And the reason I know that is because this guy over here, that's a -1. And whenever your leader is a negative, that means your parabola is going to be upside down. So I know that much, but I don't know where the highest point will be. I don't know where the other points will be. Again, there are ways to find out by just looking at the function and doing other things, but I'll explain that in another video. Right now, the other focus is creating a table and a quick table of values. So I'm going to go ahead and do that right now. So remember, it goes by input function, which is negative x squared plus 2x plus 3, and then output and order pair. Okay, so input function, output, order pair. I'm going to divide that here. And I'm going to put a 0 in the middle. And then I'll put, let's see, -1. I already know what I get with -1. It's going to be 0. So I won't put that here. I can't put -2 because I don't have space for that on the coordinate plane. So actually, 0 is going to be my top number there. Then I'll put a 1 and a 2 because I already know there's a point at 3, at x equals 3. So I don't need to put 3 in my table. So let's see what we get from this. So when x is 0, I get 0 squared, there's a negative in front, plus 2 times 0, plus 3. Now these parts with the zeros, they just disappear because they're zeros. And so what I get is simply 3, that's my output, and then 0, 3 is my order pair. So I get that point 0, 3, and that would be right over here. 0, 3 is right there. Okay, so that's my y-intercept because it's on the y-axis. So 2 x-intercepts, 1 y-intercept. Okay, back to the table. Now, when x is 1, I get negative 1 squared plus 2 times 1 plus 3. I have to be careful. There's a negative outside. So order of operations says do the exponents first. This whole thing becomes negative 1 plus 2 plus 3. And when you put all these numbers together, you get 4. Okay, so my output is 4. My order pair is 1, 4. And yet again, I get another point. So 1, 4 will be right here. 1 and 4 is right there. Okay, so I definitely know that this thing is going upside down, and I can see the curve right here along this side. All right, so last input. This is going to be negative 2 squared plus 2 times 2 plus 3. And again, be careful. You have a negative outside. Order of operations. 2 to the second power first is 4. This negative here makes it negative 4. Then plus 4 plus 3. And all three numbers together will make simply 3. And the reason is because these two cancel each other out, right? It's negative 4 plus 4. They just eliminate each other. All right, so my output is 3, and I get 2, 3. So that's going to be right over here. 2, 3 is right there. All right, and now I have a very balanced idea of what this picture will look like. So it's going to go up, hit that top. This is the highest point on the parabola. It's called a vertex. It's the highest point or the maximum point. Swings down, cuts through there, my other x-intercept, and it keeps going. So let's graph this thing. So it's going to look like this. I go up, touch that, swing down, keep going all the way, past it, all the way. Okay, and it has to have arrows at the two ends because parabolas, like lines, are continuous. And there you have it, everybody. So from factoring and solving to get the x-intercepts, to creating a table to get additional points so you can make a smooth curve, this is the way that you can graph a quadratic function. One way. And again, there are others. So please watch out for those extra videos. And thanks for watching. Bye-bye.